To x, I don't want x plus 7, I just want x, so I subtract 7 to cancel that out, and subtract 7 from both sides of the equals. Draw a line underneath. These 7s cancel each other out or lead to 0. So I'm just left with x on this side and 12 take away 7, which is 5. Next one, y take away 5. I'm going to add 5 to both sides. This disappears, which is great. Something will always cancel out if you use this method. Y is 14. Next one, this is, that's fine, just mark it correct. You used the wrong letter. 3 times a is 21. The opposite to times by 3, divide by 3. I can write it like that if I'd rather. Over this side, this is pretty straightforward. 21 divided by 3 is 7. What happens here? Well, the 3's cancel out. Now you'll notice that each time we do this, something disappears. The number we want on the same side as the letter disappears, is what we want to happen. Divide by 4. So I multiply both sides by 4. 6 times 4 over here is 24. What happens over here? Well, these 4's nicely cancel each other out, so we're left with the letter B is equal to 24. Next one, I add 15, so I have to subtract 15 to undo that addition of 15. Do the opposite and do it to both sides of the equal sign. This cancels, that's great. We've got C here. 30 take away 15 is 15, so C is 15. 5 times D is 25. So I think, what's the opposite to timesing by a number? Dividing by that same number. Do it to both sides. 5 fits into 5 once. 5 fits into 25 5 times. A subtraction of 8, my opposite is adding 8. Both sides. I'm left with, well, 11 on this side. These cancel, and E over here. Dividing by 7, my opposite operation, multiplying by 7. 14 on this side, 2 times 7. These 7's cancel each other out, and I'm just left with F is 14. Subtract 20 from both sides here, because I'm adding 20. That'll cancel out. G is equal to 30. And the last one, 9 times H, so I divide by 9. 9 into 9 goes once. I'm left with H, and 81 divided by 9 is 9. Give a score out of 10.